All right, next up we've got Christopher and Ben. Hello, guys.
Hello.
Hi, Chris.
So tell us a little bit about yourselves.
Hey, I'm Chris. I'm currently CG supervisor at Arx Anima. I started out in the industry in games, but rather quickly figured out actually that I wanted to work on high-end visual effects productions. So basically packed my stuff and moved to London, where I got a job at The Foundry. And basically then after a while, I switched into production and joined Double Negative as an effects TD and worked there for quite some time after I joined Arx Anima 4 years ago.
What about you, Ben?
Hi, I'm Ben, and I've been doing 3D as a hobby for a while, and now for over 9 years been working at Arx Anima, focusing now mainly on pipeline, but also with a bit of a generalist background, and especially happy to be doing Houdini and USD now, especially considering all the powerful features we have there.
Excellent. What's your talk today going to be about?
Yeah, our talk is basically going to be about our most recent feature animation movie and how we have built a completely new pipeline for it based on USD within Solaris and Karma.
And we'll be talking a bit about the way we build up assets, shots, and a nice mix of how we use Houdini and in general USD, a bit of the insight into our pipeline.
Excellent. Looking forward to it. Let's jump in.
Great.
Hey everyone, thank you for joining our talk about Houdini Solaris and Karma in production. We are really excited to be here and present at the FMX on behalf of Arx Anima and SideFX. My name is Christopher Hees and I'm the CG supervisor at Arx. On my right side is our senior pipeline TD, Ben Lutz. Together, we will show you more detailed insights of our pipeline and the use of an emerging new technology in our industry. We are going to talk about one of our most recent projects and how we have built a new core pipeline by using Houdini Solaris and Karma. But first of all, let us give you a brief overview of our studio. Arx Anima is an award-winning animation studio in the heart of Europe in the city Vienna in Austria. Currently, we are around 30 people, and depending on projects, we also tend to increase our numbers by a great amount if needed. We are a crazy bunch of international creatives that enjoy the challenge and have fun in the process. The talent, passion and resilience of our artists, combined with our embrace for technological advancements, allow Arx Anima to create high-quality work and keep up with a never-sleeping industry. We have multiple departments specializing in different areas. Our long-form department that takes on bigger projects, such as feature films and episodic TV series. Then we have our special format department that focuses on advertisements and projects for shorter periods of time, as well as projects that include our very own motion capture studio. Our visual effects department, and finally our intellectual property department that focuses on developing new IPs. Let's have a quick look at our show reel.
So you're a tough guy, like you really rough guy. Just can't get enough guy, just always so puff guy. I'm that bad type, make your mama sad type, make your girlfriend mad type, might seduce your dad type. I'm the bad guy. Duh. Control, even if you know that you don't own me. I'll let you play the role. I'll be
The project we are going to talk about is the not yet released feature animation movie called Rabbit Academy: The Egg Force, directed by Ute von Münchopol. We are currently still in production. The movie is a co-production between the film production house Accord Film in Germany, the animation studio Arx Anima in Austria, and the film production house Zero, also in Germany. Funded by multiple agencies across Germany and Austria, brought to the global market by Solar Media, and distributed by Leonine Studios. In September 2019, we started our first talks about this new project, what it involves, what are the requirements, and what outcome do we want to achieve by the beginning of 2021. The first movie, Rabbit School: Guardians of the Golden Egg, was released in 2017. We used it as our basis to determine the scope and complexity for a sequel. While the first movie was created with 3D assets in a slightly more cartoon-style direction, the second one was required to have a stronger 3D appearance as visual enhancement. Another one of the requirements was to partly reuse existing assets again. Not just from the original movie Rabbit School: Guardians of the Golden Egg, but also from another movie called The Elfkins: Baking a Difference, in which Arx Anima was also involved by doing the lighting for that movie at that time. As we all wanted to create a visually more advanced movie, it was also required to rework certain assets to fit to the new style of the sequel. We will show you some comparisons later on in the presentation. You probably can imagine, mixing assets from different production houses, different projects, as well as creating new additional assets creates a certain complexity to deal with. In addition, some of the assets were created with a very high polygon count. For example, a background tree with more than 20 million polygons. While in many of today's productions, these numbers are very usual and fine to work with, for boutique studios like Arx, this could be a challenge. So we needed to find a way of how we can make all of this complexity and heaviness work for us, without making any sacrifices on the overall quality of the movie. And that is how we ended up with Houdini Solaris and Karma. So why exactly Solaris? We were always trying to do our projects with Houdini, based on the simple fact that it allows us to create efficient and procedural workflows for any production. With the release of Houdini 18, SideFX introduced Solaris, which is basically the implementation of USD within Houdini. So what is USD exactly? USD stands for Universal Scene Description. It was developed by Pixar, and to best describe it in their own words, as the first publicly available software that addresses the need to robustly and scalably interchange and augment arbitrary 3D scenes that may be composed from many elemental assets. Basically, USD allows you to work between different applications, assemble and organize any number of assets or animations into sets, scenes, and shots, and edit them with a consistent API. Needless to say that our pipeline guys really wanted to get their hands onto it as soon as it was publicly available, in the hopes of making their lives easier and having to deal less with those pesky questions from the artists and supervisors. After a few months of testing multiple scenarios, setting up test cases, as well as verifying all the needed production requirements, we ultimately made the decision at the beginning of 2020 to use Houdini Solaris and Karma in production. As it is a new product within Houdini and a new technology, we of course expected certain challenges ahead. We were confident in our ability and experience to move further and take this step. It also helped knowing the great support from SideFX and their continued help for our questions and requests over the time. Unfortunately, we will not be able to show you everything we have done, but will focus on assets, look development, scene assembly, lighting, and effects. Let's start with one of the first departments in a 3D production, assets.
Thank you for that introduction, Chris. We will now take a bit of a closer look at the hierarchy of our assets and how we build them up in Solaris using LOPs, and a bit about the composition arcs used there too. Now, before we look at the hierarchy in more detail, let's quickly talk about variants. Variants in USD are very handy and are used, as the name implies, to vary any kind of parameter or hierarchy, etc. We made great use of them by having variant sets for geometry aspects like subdivision or level of detail to save performance. And especially for different shading variations, whether they are shot or location specific ones saved on the asset. And even use them for such things as lights attached to the asset for some of them, or for asset-based effects that might be steam coming off a pot or smoke from a chimney. Here we can see now the main groups of our hierarchy. Underneath a top group for the asset, we have the geometry, materials, and for some assets, lights, if they are used. Next to it, we see a simplified version of the corresponding lob nodes that are used to build up the hierarchy and asset contents. Every asset will at least consist of a geometry group and contains all the geometry to be rendered, and of course materials for shading and lighting. Some assets also include lights within the hierarchy. For example, the cell phone might have a light attached to the screen. And sometimes we even include volume effects in the asset for convenient and easy placement in the shot. In the end, everything is written out to a USD file and is then ready to be used in our shots for lighting and rendering. Now let's jump right in and look at the first part of any asset, the model. The model in our case is loaded as an already exported USD file, but it could be anything, an Alembic, or even be created in Houdini directly. We load it in with a load layer for editing lob, and then proceed to clean up any unused attributes, like potentially colors from baking, extra UV sets, anything we don't need to only have the minimal needed attributes like points and topology to make it streamlined for rendering. Our models not only include regular meshes, but can also contain point instances for things like leaves or even curves for the straw we see here. Finally, we prepare some extra primbars for comp, cryptomat per mesh to be able to address individual parts, and a rest position attribute that we can see here. Everything is written out to the geometry USD file, and we are ready to proceed to the next and the most important step for us, the materials and the shading. Materials are already predefined when we start assets, but there is now the opportunity where we can process them. We can leave them unchanged, adjust individual parameters, or even have the option to completely replace it with a different shader. For example, a custom shader for leaf translucency effects and such. For shading, we also set up variants that can later be selected in the shot for each asset, with potentially updates specifically to a few locations or even an individual shot. All our materials use Houdini HDAs and refer to the cache code directly via the source asset parameter. We also add the inherit USD composition arc to our materials, which allowed us to later easily overwrite all materials for all assets in a shot. The result is again written out to a USD layer with all the materials and variants in them. Some assets also include lights on their own, which are located in a separate group underneath the asset root group and will then be constrained during the animation phase. Variants allow us to simply enable or disable all lights or switch between different versions if it is so required on a per shot basis. And then again, the result will be written out to the light layer. Finally, some assets also include volumetric effects. Here we can see some smoke coming out of a chimney. This is set up by an exported VDB sequence that has been created in Houdini, of course. The volume is simply loaded in with a volume lob, and to have animation, the file name parameter is just animated with an expression and saved out for every frame in the USD cache. Of course, the volume also gets a material assigned, and to be able to easily enable or disable it in a shot, we again use a variant set. Afterwards, it is written out to the effects layer, and finally, we have all the parts of our asset ready. To recap, let's look at the final composition. We have our main asset file that then sublayers all the other parts written out to a separate USD file with a configure lob from geometry, materials, and the optional lights and effects. For viewport and rendering performance, we also include proxy and level of detail in some assets. This kind of approach prepares us for future workflows where departments might already provide final USD files themselves, but also proved very handy in debugging and adapting different parts when it's just about looking at materials without having to load a heavy geometry file. And with that, our asset is ready to be used.
Talking about assets, the look development of those was one of the most substantial parts of this production. Here, we basically defined what is possible and what is not. that we have the artistic freedom we need to achieve the look we want. One of the great advantages we had in Houdini while creating our shaders was the flexibility to use them in Karma and in Mantra. So for a short period of time, very early in the project, we were testing and look developing assets in both render engines, until we had all our unique shaders working and verified to run smoothly within Karma. On a side note, we could also see the great difference in render performance between both engines, which leads me to the very important point as well, that during look dev, we were already able to make more accurate estimations of future render times based on our fully textured and shaded environments. As mentioned before, one of the tricky parts of this production was to assimilate assets from different projects, having different styles adapted and adjusted so that they now work together. Let me show you a few examples of some assets from previous productions and how they have evolved for this project. Here you can see a kitchen pot and how it was used in the previous production. And this is how it got reworked and adjusted to fit into the new movie. Refined shading and more distinct differences in materials such as metal and wood. Overall, more detail and information got added into the textures as well. Another good example is this tree. Besides its trunk being upgraded in texturing and shading, also the leaves went through further adjustments. Actually, one of the bigger changes on this project in regards to shading was the use of translucency, adding more liveliness to vegetation. Characters, always important in animation. As we wanted to keep the characters close to the original and still fit into the upgraded world, we decided against the use of hair and fur and instead developed a shader that allows us to imitate those features without changing the appearance of each character too much. Here are some close-ups that show the upgrades of the textures, as well as some of our fur shading features. If you look very closely, you can see one of those features on his head. Let me push the reflectiveness a bit more. Now that's better. The reflection of his fur is behaving the same way as proper 3D fur would do, to a certain extent of course. We have achieved that by creating vector-based texture maps for each character. Another very useful feature was the control of the color variation between hair roots and hair tips. This allowed us to very quickly adjust the character's hair colors during look development without the need to go back to texturing. Here are some more images from some sets of the first movie and how they have changed for this one. A very useful feature in working with Solaris was the use of variants. They basically allow you to create multiple variations of the same asset. Ben already showed you a bit about them before, but to demonstrate some further examples, variants for multiple texture variations. Or simply variants for different shading presets. Besides having different shading properties set up, it also gives us the opportunity to add lights into variants. And finally, we also implemented effects into the assets as variants. Internally, we defined them as asset-based effects. Basically pre-cached simulations that work specifically with that object. For example, the boiling station, already shown before. Or like this chimney smoke simulation. All of that makes it a lot easier for the artist and allows them to simply turn on or off certain features on a single asset with one click. The amazing thing about this is that you can also do that on entire locations and have them adjusted to the needs of a sequence. As a quick demonstration, we have created some more extreme examples, such as different color adjustments, or even updates on the set layout. Variants give us the opportunity to set up multiple variations of a location and allows the artist to quickly choose the best working option for the shot. Ben will give you now a more detailed explanation of our locations.
Locations are our main building blocks for the environment of a shot. We will be taking a bit of a closer look at the technical details of how they build up in USD and also what we do to get them ready for lighting here with the locations in LookDev. A location, such as the one we see here, is made up of a bunch of sets which are referenced in USD files and placed within the hierarchy. Now zooming into the set level, this is where the actual assets come in. They are again loaded in as references and placed within the hierarchy. Due to the large amount of assets contained in sets, we made great use of instancing wherever possible to save performance and resources. This was especially important for things like grass and scattered vegetation, the forest, etc. We used native instances whenever the total amount of assets wasn't too big or when there were cases that would likely require more specialized adjustments in lighting for a shot. For things like the forest and vegetation further out, and especially the grass, we made great use of the point instancers for its superb efficiency. Whether it is a single asset or one of the instances or even a prototype of a point instancer, they are referencing the asset USD file which brings in the geometry and materials etc. which we looked at earlier. The final result of this composition is a hierarchy where sets are nicely grouped in locations and those sets contain all the assets. Within them we have access to geometry and everything else that is part of the asset. For some of these scenes, the final prim count can easily exceed over 100,000 prims if we count all the material elements, meshes, etc. Now that we have everything built up, we can start making adjustments to the location to prepare it for rendering. The first part of this process is to define a variant set where we can easily switch between interior and exterior location setups. For example, if the camera would be inside a house or a cave, then we can pretty much disable everything around it for performance and sometimes also to avoid intersections of geometry that would only be visible from one side. This is done simply with a configure prim or prune node to disable the desired sets or individual prims. The most important part about preparing a location here in LookDev is of course all the tweaks that we make on materials etc. to get the desired look of a location as a whole. One part of this process is selecting the shading variants which have been set up on the assets already to match the one that should go in the specific location, which might be a darker version of a tree, for example. It is not just materials that we have the opportunity to edit here. Thanks to USD's and Houdini's powerful editing methods, anything can be modified, even geometry, in case a location requires that. One big topic was the modification of the point instance grass, where adjustments include not just simple shading variations, but actually transferring textures from another ground geometry or adding a bit more variation to the position, orientation and scale of the individual instances. To make this process easy for the artists, we built a custom HDA that wrapped up everything we needed to allow modifications, tweaks, etc. Let's take a closer look of what goes on there under the hood. Here we see the setup in SOPs, where we use the lob import to load in the desired point instancers points, and the ground plane as a reference, which will be used to transfer texture onto the grass. After some pre-processing, we transfer the ground plane's UV coordinates to the point instancers points. That way we can sample the texture directly and not have to worry about the geometry resolution of the ground itself. Afterwards, artists have the opportunity to use color correction to further tweak and refine the look of the grass. Position, orientations and scale can be further adjusted to give it a bit more variation where so desired. All that custom shading information is then written out to the point instancer with primvars, which Karma will then pick up with no extra steps needed, and so allow us to modify any shader attribute we need even on a per instance basis. With all the tweaks done, the location is exported again to a bunch of USD files and ready to be used. Besides tweaking the look of locations, we also start preparing lighting templates which allow us to easily reuse the same lighting condition which is used across multiple shots. Light conditions again are set up in Houdini with variants. Besides adding lights, artists can also reference in special geometry for blockers and of course use any of the adjustments we've just seen if it is necessary to tweak it on a per light condition basis. With both the location LookDev and the lighting template done, we are ready to move on to the actual shot work.
Thank you, Ben, for mentioning the templates and how they have helped to make our lighting process more efficient. Lighting. In my opinion, one of the most, maybe even the most, critical part within a 3D pipeline. Not only from a technical point of view, but probably also from the artistic side. On many projects I had the pleasure to work on, getting the lighting pipeline working was always one of the biggest challenges. You might think that how can it be so complicated? Just load your scene and place some lights. Surely that can't be so difficult to set up. Maybe, but doing that in an automated way for thousands of shots with potentially thousands of assets, receiving data from multiple different studios, from multiple different departments, and having to set it up in a way that many artists with various skill levels are able to simply place some lights and render successfully, then yes, this can become quite complicated. Basically what it means, in lighting we are combining the look depth assets with the output of the layout department, with the output of the animation department, and the output of the effects department into one place. We call this whole process shot assembly. And when all of these inputs get successfully assembled, we finally have a complete shot ready for further progress. So, how does this work in our USD-based pipeline now?
The process of assembling shots in USD actually starts out with the Alembic caches we receive from animation or layout. With the Alembic caches also included is a preview of a shot such as the one we can see here. Every shot is made up of the same Alembic files, one file for each type of asset we have in our shot that includes locations, characters and props. In addition, we also have a file for the camera and a special case we call rigged elements, which are just animated parts of a location. The important part here is that every Alembic file already contains the hierarchy matching the locations and assets that we have prepared in USD so far. The fully automatic conversion of ABC files to USD starts with a cleanup using USD's powerful Python API to load in the Alembic files. The cleanup process starts by removing some redundant groups and renaming certain prims to make sure it one-to-one matches everything we have set up here for the assets in USD. Next, remove all attributes except points and transforms, because topology, UV and all the other stuff will be coming from the assets already existing in USD. This results in more lightweight files, but also has the advantage of not having to worry about if the rig used to export has the latest version of UVs, for example. Furthermore, we scan the animation and detect any constant values and replace them with just a single default time sample, and also deactivate anything that's constantly invisible to further reduce the amount of active prims in the scene. With all the elements prepared, we can now start the assembly of the shot. We do this by referencing in the assets based on the name from the hierarchy. For every prop, location and character contained in the shot, we reference in the corresponding USD file to actually have the assets appear in the shot. Then we layer on top the cleaned up USD files which just contain the animation overrides, and now we have for the first time an initial version of the shot ready in USD. The next step in the process is setting up variants from Shotgun, which is setting inside or outside for the locations and activating any potential asset effects we showed at the beginning. Furthermore, we scan the scene for any lights on assets and constrain them to the animation now that we have both animation and assets actually loaded. We also add an additional Cryptomatte primvar to allow easy access to individual assets in comp, and even set it per top level point instancer in case point instance assets need to be addressed individually later in comp. Finally, we tune the scene for performance by using a camera frustrum based optimization, where we set the level of detail and disable parts of the scene further out that will not have a significant impact on lighting. This process works in two stages. First, we expand the camera frustrum and check for all frames which parts of the scene are always far enough away to never have any impact on the shot at all, and completely deactivate them based on a predefined distance. Next, we further refine it by checking which assets are actually directly visible to the camera and which ones will only affect the shot in an indirect way. For the indirect ones, we select a variant with significantly reduced geometry, and also materials have been baked into a display color primvar. This not only results in a reduced complexity for rendering, but also significantly reduces the amount of prims active in the scene, thereby making the shots more responsive for lighting artists to work with. This was not just about performance considerations due to the huge amount of points in total to be processed, but because sometimes it was necessary to set up new instancer prototypes. This was required when the same prototype was used in both direct and indirect areas at the same time. With that, we have all the parts ready for the final composition of our shot. It starts at the animation and layers on top all the configuration files that we've just talked about, like Cryptomatte and the level of detail. Then we load in a placeholder effects layer and a preview lighting layer, which just includes a dome and distant light, as well as preview render settings for Karma. We use Karma to render out previews and take advantage of the consecutive frames rendering feature, which has the advantage of only having to load and process heavy scenes once, and then can quickly render all subsequent frames. At the end of this fully automatic process, the USD shot is ready for lighting, and the preview MOV waiting to be checked.
Once we have that preview of an assembled shot and also verify that everything works fine, we finally can focus on lighting. The movie contains 88 sequences, for which we ended up creating around 70 different light conditions, often adjusting the sun direction for every sequence, but always trying to give the audience the feeling of time progressing through the movie. It is always great to work on a project that offers you the opportunity to create a variety of moods within lighting. On this work in progress mood table, you can see the vast amount of different colors being used in multiple sequences. This, combined with beautiful locations and action-packed animation, should make this family movie a fun and exciting experience. As this movie is still in production, we are unfortunately not able to show you as many shots as we would like to. But here are 2 examples of how a shot evolved from the concept art to the final image. Not only are there many different light conditions, but also a great variety of locations, such as a big welcoming house surrounded by fresh-looking nature. Deep dangerous forests that have you run for your life. Or a mysterious mountain with a hidden secret. Besides many more. As you can see, vibrant colors play a very important role in the Rabbit Academy. It is often not the easiest or the fastest solution to try and get them working perfectly during the lighting phase. Luckily, there exists a compositing department, our saviors in desperate times of need. And to make their lives as comfortable as possible, there are always the questions of how do we want to render? With which software? What render passes would be helpful? What AOVs are needed? What should the render settings be? And so on. By using Solaris and Karma, we could make certain aspects of the pipeline more streamlined and a lot easier for our pipeline guys. Ben will go more into detail shortly. Rendering in Karma was a big challenge. When I read this sentence from Sakyong Mipam Rinpoche, it made me chuckle and I found it quite fitting sometimes. But from my past experience, I probably could say that about any render engine. Karma is completely new within Houdini, so there's not a lot of material and shared experience out there. Of course, we expected to run into issues, such as bugs and certain features not integrated yet. However, based on our research during the pre-production, we verified and made sure that everything that is needed is there and works. On the basis of our previous experience in Houdini, we were very certain to find workarounds in case something really is not there, but would be mandatory for us. Here also a big thank you to SideFX for always supporting us and taking care of bugs very quickly. Often within the next build, we already had a fix. Ben will give you now a bit more insight into our lighting pipeline.
Lighting in Houdini starts by simply loading in the previously assembled shot, which includes everything we need, like assets, animation and so forth. Here we see a simplified lob node setup of the template that artists use to light a shot in Houdini. We again separate out different parts into individual USD files, which not only makes it easier for debugging again, but also provides us with the option of potentially reusing parts from one shot in another. Besides loading in the actual shot, it was sometimes handy to also load cameras from the same sequence and possibly other elements as a visual guidance. This is all followed up by a layer break, so none of those extras get written out to the shot. As a first step, we used the inherits previously set up on the asset to update all shaders easily to the latest version, possibly further configure some variants like the asset-specific effects coming from Shotgun specific to the shot, or other general settings and configurations. Next, we load our predefined render templates as a sublayer followed by possible adjustments on a per shot basis of preview and final render settings. The next area is used to adjust anything that might be required to be tweaked, like materials mostly, but also anything else like geometry, further variants, or render geometry settings. With USD and Solaris, there is no limit to what can be changed if it is necessary to tweak it at the lighting level in a shot. Finally, we reach the main part where the actual lighting happens. Here we start off by first loading in the location-based template we talked about earlier, and then there's an opportunity to either edit the template lights or even create new lights specific to a shot to achieve the desired look. All those different parts are then sublayered into the main lighting USD file. At the end, we have another layer break which separates out the general edits per shot with the path-specific setups used to create render passes for comp. We decided to call these elements passes to not confuse them with the USD layer terminology. The way we set up those passes is simply by creating one more layer that just contains the path-specific overrides, which is then loaded over the general lighting shot. With this being the strongest layer in the stack, this allows us to override anything again we need to create the path-specific overrides. This can go as far as modifying geometry, but mostly is about deactivating other elements, setting up render visibility such as phantom and matte, possibly tweaking some lights, or replace all elements with a simple ambient occlusion shader. We also split out elements such as particles and volumes into separate layers to make it easier to adjust to the specific render needs for them. With everything ready, it's time to submit the shot to the farm. A custom HDA takes care of submitting all the passes and also handles saving out all the required USD files. Here we see some example passes of a shot, the direct rendered output from Karma. We also took advantage of Karma's flexibility when it came to setting up EOVs, which made it easy to quickly generate masks or custom EOVs for comp. Overall, creating a USD pipeline that uses Karma as the Hydra delegate for rendering has been a great experience, and we're looking forward to all the new upcoming features and improvements for Solaris, Karma, and USD.
And our last chapter? Effects. Probably the area in which Houdini is the most famous in. At the beginning, we imagined this could be a bit of a problem within our USD pipeline. This can only end up in a mess, constantly switching with various assets and effects between subs, DOPs, and LOPs. It sounds very time-consuming and error-prone. On the contrary, after some brief investigations, we actually realized that this is no problem at all. And we have created all kinds of effects. From simple floating particles, or let's call them fireflies. That sounds way better. To volumes such as steam or fire. Color bombs, because we can. And of course, magic effects. Ben will show you now why working with effects was so straightforward.
Dealing with the USD side of effects really turned out to be quite straightforward. Once we had established all the other components of our USD pipeline, effects became basically just another layer among many in the shot. Because everything was done in Houdini, going back and forth between subs, LOPs and DOPs was a pretty smooth experience. For the most part, it was about reading out specific parts of the shot from USD into subs, to be able to use them for dynamics as reference or to be modified, and afterwards writing out the resulting changes or newly created elements to one or more USD files. The way we set this up to make it efficient for the artists was by providing a template that already had predefined areas to load in specific parts of a shot into subs. Mostly this was just a bunch of LOP import and unpack USD nodes to get the data ready. Once the data has been imported, it became more or less a classic Houdini workflow without having to worry too much about the specifics of USD. When dealing with simulations, we found it handy to scale our scene content to SI unit meter scale and then back when exporting it out again. Effects might include things such as modifying existing geometry or create completely new geometry in addition to the already existing elements of the scene, such as volumes, particles, and debris, for example. Once the effects are done and approved, it is time to write them back out from subs to be able to use them with USD. Before writing out the data, we remove any unused groups or attributes to only keep the ones needed for lighting and rendering. We scale it back to our scene unit scale, and for each effect we export a separate USD file containing the geometry, and for cases where there are volumes, a sequence of VDB files. With all the data exported from SOPs, we are now ready to go back to LOPs and assemble the effects USD layer. The LOP node setup to do that is again pretty straightforward and starts by sublaying the shot, followed by a layer break in the same way we did it for lighting. Then we load in with a sublayer the exported USD geometry files, and also have a volume LOP to load in the VDB sequences in case there are any volume effects. Similar to assets, we have a separate layer where we place all the materials, which can be newly created ones for new geometry or adjustments of existing in case geometry is modified. And finally, we have some render geometry settings, because effects often require some additional settings, such as enabling velocity blur to have them render motion blur correctly. In the end, everything is written out to the effects layer, and when lighting starts, this layer is already included in the shot. That means artists don't have to do anything to have effects available in lighting.
Overall, I have to say that our USD pipeline created within Houdini Solaris ended up being very efficient and flexible to the needs of this production. We managed to finish more than 1,200 shots within less than 6 months with 3 pipeline TDs, 7 lighting and 2 effects artists. Of course, everything you have seen in our presentation was a massive team effort. And finally, I have to say a big thank you to everyone involved in the production of the Rabbit Academy feature animation movie, as well as a thank you to SideFX for inviting us. Arx Anima is always looking for talented artists, TDs, production managers, producers, and many more to join our team. So please don't hesitate to drop us an email or send us a message. Thank you for watching.